Okay, I'm here to talk to you guys about perfecting your e-commerce front end for various loose definitions of perfecting. Last year I did the same talk in Washington, well, almost the same talk, very similar. And I had to shout at everybody, and so a lot of you guys didn't hear me, which is great because you're here today, and I have this microphone, this beautiful venue and projector, and you'll be able to hear me. I'm Denis IRL. I am Jump Hacks IFL. And this is how I justify my online handle. That's me in Connecticut. This is what I consider IFLs. Be careful, there's a little bit of trolling on some of these, so just watch out. I don't mean everything I post. And so I like very quick things, and one thing I also want to say is I made this talk to be very actionable for everybody. All the store owners that want you to be able to go back to your company and throw this at your developers, all the developers that want you to be able to go back and demand a raise after you execute some of this stuff, because this stuff, like we just heard, translates into real money, and real money is great for real salaries, which I'm sure you all like. So I like quick things, and that's me right there. I like motorcycles and cars, and being faster than others is really great. As we just heard, I had the perfect talk right in front of me about performance, and I'm going to talk about the other side that completes that performance, which is on the front end. Real money is real great. Exhibit to illustrate the concept here. You're on the left, you're passing your competitors, and it's really great because you're getting these emails from your customers that just praise you for your performance. But it involves a little bit of work to get there, and I'm going to walk you guys through it. Also, one thing you should know, all of this talk uses no caching. All of the figures you're going to see are from our real app deployed in the wild. Some of these benchmarks are up to a year old, and whenever I'm not using a technique that is in this talk, I'm going to try to give you guys a heads up and tell you we didn't actually use this, so it could have been even quicker. I like to work on my things to make them quicker. And it's totally worth it. I'll show you how. So this performance work thing is how I met FCP. And if you go to Google and you type in FCP, you're going to get Final Cut Pro. I'm not talking about Final Cut Pro. I'm talking about foreign car parts. The CEO and our creative director are here actually today. Woo! I've been with them for 4 years. That's 4 tech job years, which translates roughly to 20 normal job years. And I'm like 20, so I've been working for them like my whole life. I love them. They're the best. So getting the most from your front end, right? That's really a trap of a title, because really what I mean is getting performance from your front end. It's actually me here today pitching to you guys, so when I go to use your store, it's really quick and I don't get annoyed, and the internet is better for me. That is my motivation to be here today. Here is an HTTP waterfall chart from one of our biggest competitors they're publicly traded, and they don't spend a lot of time optimizing this kind of stuff. They just throw it all up on the quickest hardware they can afford, and this is what you get. The screenshot is taken from Google PageSpeed Insights, which is a tool you can go and use for free online. It is the best out there. It will just tell you everything that is wrong with your website and exactly how to fix it. And what you're seeing there actually in the middle are iframes. And that's 10-second iframes, more than one, which is really bad. You don't want to find yourself in that situation. There is this guy out there, and his name is Steve Souders. I think that's how you pronounce his name. He's a performance evangelist for Google, and he really knows what he's talking about. He's really legit. You know that because that's a real photo, and it has velocity and performance in the same photo. Guy's really clever. No, really, but though he's a published author, and this is a book he wrote, High Performance Websites. It is basically the Bible to front-end performance. It's the best thing that's been written. And that wasn't enough, so he went out and he wrote this thing, better performance with O'Reilly. And he has a blog post that is really, really instrumental to all of this, and it's the performance golden rule. So he says that 80 to 90% of the end user response time is wasted in the front end, and you should start there. And he backs this up with data. So what you're seeing again is an HTTP waterfall chart. There's going to be a lot of those. Because it illustrates a few important concepts like page blocking and all that good stuff. So he did very naive benchmarking, and you'll have to forgive him, but I think the wisdom stands. He tested the top 10 websites at the time, which was like 2 years ago. And he found that the split is actually a lot more balanced than most websites because these companies can afford to spend the time and resources optimizing their front end. 24% is spent on the back end, and by back end we mean the time for the signal to go to the server, for the server to generate the response, for that signal to travel back. The rest of the work we consider front end. Everything browser does from that point is front end. And with websites down the line, with the top 50,000, it's actually even more drastic, and they're much slower. 13% is spent on the back end, and a whopping 87% on the front end. Same blog post. You should all start with that blog post. It is gold. So why am I talking to you today about this topic? Well, not to brag, but we're kind of a big deal with what we accomplished with FCP, I think. Good figures for what we do. Like I said, no caching was used anywhere, mostly because the way we sell car parts, and the unique combinations of the year, make, models for the amount of makes that we sell comes out to an insane amount of product browsing pages, and we have 100,000 SKUs, and it's just not very viable for us to cache that in the traditional Rails sense. So we run queries on every single page. This is a screenshot from Pingdom, front-end testing tool, and that's a BMW parts browsing page, which is one of our most expensive queries because it matches an insane amount of products. So from their data center in New York, they made 54 requests. They downloaded the whole thing with everything that the page required in 554 milliseconds, and 330-something kilobytes were downloaded. They said at the time this was better than 96 websites that people were testing, which in itself is biased because people who test their websites generally work on the performance of their websites. Then we went to Google, and this is a little dated. The tool is now a lot more sophisticated and provides a lot more suggestions, but at the time, Google gave us a 99 out of 100 and only had 4 low-priority suggestions on the left. Amazing tool. Again, if you're going to do anything, please use this tool. It is awesome. Here is the chart that they provide after you run the tests on your page. And what you're seeing here is, again, in blue, the server response time. In yellow, you see the JavaScript, and in green, you see the style sheets. We were able to start drawing on the screen at 300 milliseconds, and we were done completely at 740 milliseconds. This is a page with that actually ran full text index queries on Solar and also displayed 20 product images. So let's begin this optimization talk with talking a little bit about CSS. You guys all know what that is, right? The very first thing you should know not to do is the overqualification and very high specificity in selectors found on the web today. And what I mean by that is the parts on this selector, which are space separated, are very high. You don't need this. First of all, the selector all the way to the right is an ID, and by definition, that should be a unique element on the page. You shouldn't ever have to qualify an ID, unless, of course, you're doing some kind of layout overrides or something like that. So none of that is necessary. But even if it wasn't an ID, you want to avoid the extra parts to a CSS selector because what the browser ends up having to do is run DOM subqueries to ensure that those elements are actually up or down in the DOM tree. That is expensive. So the selector on the very far right of the composite selector is called the key selector, and that is because it is key to your performance. Something I didn't know until I did the full research on this talk is that browsers will parse your CSS selectors from right to left. The rightmost part of the selector is the most important piece of the selector. And then they'll run subqueries going left from there. That brings us to CSS selector performance, which is very different for different types of selectors. The best possible performance you can get is using IDs and classes. That is because those are always indexed. And not only that, those are custom strings that you put into your code and your CSS files, which means they're going to match the smallest amount of elements on any given page. Second, we have adequate performing selectors, I like to call them. Shout out to Tenderlove. We got tags, sibling, children, and descendant-based combination selectors. All tag selectors in all modern browsers are still indexed, but the problem you run into is that they match a lot of elements on the page because those are reserved keywords in the specification of HTML, which will naturally match more than a custom string you put in your class or your ID. So not ideal, especially if you use something like A. Like that's going to match elements, way too many elements, and you probably mean to match. And these things, just please avoid them. These are all sorts of slow selectors. The universal selector will literally match everything on any given page, slow. Attribute-based selectors, where the query has to be actually performed and walked linearly on the page, because those are not indexed either. Pseudo-selectors like nth child, and you can even run a regular expression-based selector on attributes, which you can imagine isn't very fast. Previous versions of Bootstrap and Zerb CSS foundations made use of these, actually. And that wasn't good. But in recent versions, they've brought attention to that and corrected it. And it's much better now. There's a tool out there called CSS Explain, which will help you quantify and benchmark your own code if you actually want to get that granular with it. You give it your composite selector, it will score that selector for you and tell you why it is good or why it is bad. And I'm sure if you run some clever code, you can actually automatically go through your CSS file and compile this. And as you refactor, especially if you use something like Sass, it recompiles down to new style sheets, run that style sheet through the same piece of code. Same piece of code, you'll get updated scores. Here's something you should all be doing if you're using the wonderful feature that is the Sass abstraction layer over CSS style sheets. You should be looking at the generated CSS files, which I wasn't always doing. And I got Chrome 25 to like crash and just freeze and do all sorts of things. So I'm like, something's wrong with my system. I went and used my coworker's Mac-based system, same thing. Well, open up the CSS file, see something like this. Not very good. So specifically, the reason this is happening is because of the dangerous combination of nesting and extending in Sass. So if you don't want to learn about this, just don't use extend. If you do want to learn about it, realize what extend does and use it very, very carefully. And especially, like the red flag is just you're nesting deeply and you're using extend. So basic CSS wisdom comes down to this. Use shallow, reusable, utility-based CSS classes. That is going to get you a very fast front end. Google's PageSpeed now actually also recommends some very interesting things that I hadn't considered before, like inlining the essentials and the basic layout utility classes to render everything above the fold. And by inlining, we mean put that right into the HTML head within the style tags. So as soon as the browser starts seeing HTML come through, it can already form the basic geometry of the page and has to do less reflows once the actual full style sheet is actually downloaded down the road. Let's talk about asset delivery. Asset delivery is where by far most gains are going to be had. So the original responsive definition, right, the time to start rendering the page. Again, same guy, Steve Souters, goes out and does a sample on whatever his preferred sample is. And what he finds is that half of the web pages will not start rendering until after 2 seconds have elapsed. And 1 out of 10 will just make the users wait 5 seconds before they even see anything, which isn't very good. So a good baseline is for you to only have one style sheet, one JavaScript file, and include the style sheet as the very first thing in the head to let the browser start downloading that and resolving DNS on that. And download the style sheet asynchronously, which is kind of a new thing, but not really a new thing. But more people need to start using it. And what that will do is will not block the rest of the web page. And it will download the file in the background. And as soon as the file is done downloading, at that point, the file will execute. Which is great, except it's not really that great because we cannot use JavaScript in the body of the document that's being downloaded and have it depend on the external script reference that we provided earlier in the head, because potentially that could get executed before the asynchronous completed call happens. Something that people do to refactor that and fix that problem is to place the external JavaScript reference right before the closing body tag in the HTML document. I believe the boilerplate for like Zerb actually does this and stuff like that, which, again, it's not as fast because the browser only gets the heads up that it should start downloading this important JavaScript file all the way at the bottom of the document when it's done with everything else. That's going to slow things down. So the best solution I found for this is Head.js, which is basically the nice features about HTML5's asynchronous style sheet loading, but it has a way to solve the no JavaScript in the body problem. The way it does that is it loads a very small piece of JavaScript in the head blockingly, and then you can use the provided API to load extra JavaScript files asynchronously. In the head, you can wrap all of your JavaScript with a special version of when all scripts are loaded and execute those. And none of that's going to error. That works beautifully. Back to our publicly traded competitor. To load a basic product browsing page, those guys were making over 200 HTTP requests, which is very, very bad. The reason this is very, very bad is because of something known as ping, or latency, which, simply put, is the amount of time it takes for the signal to travel from point A to point B. In our case, that is the client's browser and the server, and then back to the client browser. You pay this cost twice. You pay it once on the request, and you pay it once on the response. So if your server has the ideal response time of 0 milliseconds, it can form the full response and send it back to the client. You're still paying at least twice the network latency between your client and your browser. So that's the absolute soonest that the user could possibly start seeing anything. And that is where Asset Pipeline is awesome. Hey, Ryan. So the one thing, or well, actually many things, but one of the best things it does that I really love is the fact that I can consolidate HTTP requests into one for style sheets, one for JavaScripts. In some cases, you'll need to do more than that, but that is a very good place to start. It is the second best amount of requests you could have, which is one for each type. CSS sprites, another common technique, which basically takes a bunch of images, puts them into one file. You use CSS to reposition that file as the background on your element, only revealing a small window, thereby making it look like you just have one image tag with one ref and one image there, but that's not the case. Game developers, especially like old school 2D game developers, like side-scroller game developers, have known this technique forever. They use it for animation. Just have a bunch of animated frames and just move the image along on each render frame. One thing that is really, really awesome that not enough people make use of is the data URI scheme. You can read all about it in the wiki page, but very simply put, instead of placing image references in the style sheet, you can take the actual image, base64 encode the data of the image, put that string into your style sheet, and you're done. There is no network involved there. Once you download the style sheet, there are 0 requests. The image is already there, already in memory, already being rendered. Asset domains. The HTTP specification, well, HTTP 1.1 specification, says this ridiculous thing. No browser should make, actually it's a suggestion, it's not a strict rule. So it says don't make more than 2 concurrent connections to any one domain, which is hilarious. All browsers violate that grossly in the name of performance. All modern browsers will make up to 6, 8, and upwards of that parallel requests to the same domain. And we, like here's an example of our product browsing page. The purple is what's interesting on this page. There's the light purple and the dark purple on those bars. Those are image photography lines. All the light purple is blocking, is the browser doing absolutely nothing, sitting idly while some of the other requests from that same domain finish downloading. And this is on S3, so probably a lot of you are being affected by this. If you're showing more than 20 product images, you're affected by it even more. The dark purple is the actual network activity. That's the browser actually downloading the image. Not very good. Here is probably the money shot on this whole presentation, this right here. This is an actual piece of code we use in production. Basically what it does is it dynamically generates the asset host for the images when those guys are being put into the HTML by the Rails template renderer. And what we do here for the images, once we know that that asset is actually an image, we know that those come late in the life cycle, and we know that there's going to be anywhere between 20 to 100 of those on each page. For us, in our case anyhow, could be different for you. And what we do is we bypass the whole concurrency problem by saying that here are the 5 asset domains that these images are hosted on. Randomly pick any one of them. So with basic math, if we have 5 images and we have 5 random domains, each one up to 6 concurrent requests, we can serve up to 30 images concurrently, supposedly. And all of those domains end up resolving to one location, which is our S3 bucket. If not, chances are the asset is critical to the rendering of the page. It's something like style sheets or JavaScript or something like that. And we actually host it on an actual content delivery network. The benefit of that line alone is amazing. If you do nothing else from this presentation, do that one piece in your code. What a true content delivery network, a CloudFront in this case, will do is those guys have 21 locations all over the states, and all of the requests to your assets are being routed through those spots. If when a customer visits your website and they have to request a particular file and the file is not there, CloudFront is going to go to the underlying store and fetch the file and keep it locally. Every consecutive request from people in that area will hit that cache and will respond very, very quickly. The latency is very, very low, like 10 milliseconds, 20 milliseconds, which is amazingly awesome. Basically, it acts as a pass-through cache. And that improves things very, very dramatically. Those are the images, same exact images, stored in the same exact S3 bucket. It's just that they were routed through our asset domains. Something you can do in Rails that's a little tricky, but it's doable, is HTTP streaming. Traditionally, in a Rails controller, the very first thing you'll do, or one of the first things you'll do, is you'll block the entire everything by sending a request to your database and retrieve everything from it that you need to render the page. Once that returns, you can then start drawing the actual HTML, and then once that is done, you start sending the response. That is slow, and what we can do is we can actually start rendering the HTML right away, and as it's rendering, it's being sent to your underlying web application server, Unicorn in my case, and then Nginx, and that is being sent to the client. And only when the view hits the actual part of the view that requires the data, only then will it call what previously was just a instance variable, which is now a method, and only then will the expense with the database be incurred. Why would we want to do something like this? Well, because we can actually decrease our time to first byte in the page. Ideally, we can approach the initial server chunk, the initial response time, asymptotically of somewhere in the constant double-digit milliseconds or single seconds, single milliseconds, which means that if you pay the cost of HTTP latency once, your server starts responding right away, and you pay the cost again on the response time, you could already be resolving the DNS and starting to download the style sheets and the JavaScripts that the page will require before your server is even done generating that page and done with all the database calls, which is really, really great. Sounds like a lot of work. It may be, especially for some of the Spree stores that use a lot of extensions. But I have good news, everyone. And that is that here's a wall clock time of all of our controllers and actions that see front-end use from New Relic. And you can see that this is being dominated by the brown and the green. The brown and the green are Spree products index and Spree products show. You optimize those two templates and those two actions, and you are providing the benefit of that performance increase to, what does that look like to you? 95, 97% of your users, and that is really good. To take advantage of that, you need to be rocking a modern, more servers are starting to support this, but Unicorn, Nginx, Ruby 1.92, and later all support this, so those are requirements. One other thing you can do is you can actually provide hints to your browser, your client, with what's coming ahead in terms of style sheets, CSS files that may be perhaps at the end of your whole HTML response. You can even tell it to start prefetching PNG files and HTML pages in the background. Not all browsers support this. Chrome supports a lot of this stuff. And there is something even better. There's something that came along recently that pretty much puts everything that I've been talking about to shame. It just kind of fixes all of the problems magically, if you will, that's being rapidly adapted. It's called SPDY, S-P-D-Y, and it's a protocol that is being developed by Google. That's actually, I guess, more or less production ready. It's being used as the basis for HTTP 2.0 spec, and you can use it as a progressive enhancement to HTTP 1.1. Here's what it does in the abstract. Here's the part that we care about as a performance optimization. It does a lot more. But what it can do is, without having seen the request from the client after the initial request, it can actually initiate a stream directly to the client saying, listen, you just requested an HTML page. I know some of the things you're going to need in the future. Trust me, take these style sheets and these JavaScript files with you. And when it hits that, it will already have that in its local cache. And that is amazing. That is the biggest front-end performance bottleneck being solved right there with a protocol. SPDY usage is real. It's out there right now. The biggest names are using it right now. That's why they're so much faster than everything else. One of the reasons. Google, Twitter, Facebook, and actually more. WordPress, I heard, is using it too in some capacity or other. Obviously, browser support is a concern. But the good thing is that it degrades more or less gracefully to regular HTTP 1.1 spec if the browser doesn't support it. And as you would expect, Internet Explorer is having a tough time keeping current with the times there. And let's talk about JavaScript. Steve Souters, again, goes out and samples the web. In one test, he executes all of the JavaScript and then marks the page as loaded only after that has completed. In another test, he visits the same websites and he says, listen, just don't bother with JavaScript. There's a 31% performance improvement, and the choice is obvious here. Just stop using all JavaScript in your apps and you're good. Yeah, but I hear you say Rails 4 Turbolinks, right? That came to save the day. It's great. It's pretty good, except there's a few problems with it. And the problem with that is most jQuery, or a lot of jQuery plugins, for example, are not written to take into account the fact that the onReady event could fire multiple times, or that there's a number of issues of that sort with the guy. Like a clean JavaScript scope on each page load was assumed up to this point, and now the scope is dirtied and it's maintained through the life cycle of the user checkout or whatever it is that they're doing. Yeah, but we have even better. Look, Ember and Angular. Okay, yeah, these are really good solutions. Here's some things to know about them. Performance. These things are amazing at performance, as we've already heard, due to statefulness. And that is every time you do some sort of interaction traditionally with an HTML page, you used to have to load everything that had anything to do with that web page. The user, their cart, the products on the page, whatever else extensions you're using, everything on every single request. That is no longer the case. Now you just go to a page, you click once, you get one model loading data, you click again, you get just that model loading just that data. Really, really quick. Due to mostly the number of database requests that your server is actually performing. Not only that, but prefetched templates. The downside of this is it's extra time that the first request is going to take because all of the templates are being downloaded and kept locally in the client. The upside is that all requests you ever have to do only download JSON and then put that JSON into templates you already have locally in JavaScript. So it's very fast for consecutive requests. And also, the requests are, async. So what that means is that the client already has the layout of the page. It just doesn't have the data. So what we can do is it can actually start putting that into the DOM. When the data comes back asynchronously, it marks that page to be updated in the render loop, and that data is inserted into the page. So the UI seems even quicker than the actual network performance. If you guys use the Android Instagram app, native app, you'll see that it does something very similar, and it's been regarded well in that respect by all its users. It'll actually put the view in front of you, and then the data will appear in the view, and that's what you're seeing. And that makes it appear even quicker than it actually is. However, for small teams, which I'm a part of, this kind of an approach has a diminishing ROI. In a lot of respects, due to fast enough. If we're able to render the entire page for a user in 750 milliseconds, it's becoming harder and harder for the user to see the benefit of these kind of performance upgrades. And also assumptions about engagement. I wanted to convince my CEO that we should start developing work and move to an Ember UI. So what did I do? I went to our analytics and, wait a minute, that's not right. Most users are only on the site between 0 and 10 seconds. Hold on a moment. What about the amount of pages they view? Oops. Most users view one page and bounce. We are huge in our organic traffic because we do a lot of SEO work, and that could be the reason why. They could be comparison shopping. They could not know about our company. Whatever the reason, this is the real data from our real production live application, and that's just not very good for something like Ember. And then there's that other thing, SEO. You've already heard today that finally Google is starting to keep up with the times, and they are finally indexing JavaScript application. They're actually following the hash bangs, and they're finally rendering that stuff. That wasn't true until recently, so ignore the slide, I suppose. The popular solution today that production companies use with Ember is to actually either serve double UI, serve the static HTML that can be taken over progressively by Ember, so that if users have JavaScript disabled or if a crawler is visiting their site, they will actually see a user interface, or something like Phantom.js, which is basically a headless little guy that's going to go and load your page up and then save it as a static HTML page. If you guys Google Ember SEO, the first thing that comes up, they do that. They do that for you, and they serve that to selectively just to Google when it hits your page. But as of recently, I guess what you can just do is let Google do all the work, which is really, really wonderful. So speaking of SEO, that's also a topic with e-commerce front-end, and let's talk a little bit about that. You're already doing it. If you're following these performance optimizations, Google keeps track of this, and Google uses that signal in its overall ranking of your website. And that's been old news for a while now. I urge all of you to be very strict with your SEO firm, and don't pay money for speculation. Don't pay money for link farms. Hold informed technical calls. Ask the hard questions, and you'll be able to do all of that if you spend time and read the Google Webmaster Academy. Google tells you everything you could possibly need to know to become an amazing SEO expert. So every time you're paying somebody money to do that kind of work, it would really help if you were really well informed on the topic. Here's what happened to our websites when we decided to take matters into our own hands after receiving bad advice from a couple companies. It works. Canonicalization, a problem you didn't know you had, is a big topic with us due to the large variety of parameters to our particular website, and also the fact that we have a multi-domain setup going on, and then you have subdomains and stuff like that. I wrote something to help you guys deal with this and not have to spend the amount of time I had to spend on it. It's called Canonical Rails. And the problem of canonicalization goes down to having an authoritative version of each and single web page, basically. You might have a trailing slash on one, but not the other. It might be reachable with the www prefix. There might be extra parameters tacked on that you couldn't care about, or there could be harmful URL parameters tacked on by your competitors that are trying to link to your site saying that's what you guys sell, or what have you. The way to solve that is to include a special meta tag in your HTML head that basically for each page rendered will show what the authoritative main version of this page is. And Google will index that particular URL, and that's the URL Google will use when linking to from search result pages. Very simple to configure. You bundle, you run a Rails generator. It'll give you a few parameters to configure. Very simply, you tell it what the URL of the website is, the main domain. You tell it what kind of collection actions you have, so you can attach a trailing slash to those. And then you tell it all of the possible parameters that you want indexed, that you want to allow people to land on. And then just include that helper, and it's really quick. It obviously doesn't do any database calls or anything. Very important topic for all of you to consider is semantic markup. It's a way to describe data design documents for humans to machines that they can use and parse more effectively. You can describe any kind of content here. As you can see, events, TV series. What we're interested in e-commerce is products, offers, aggregate offers, reviews, and aggregate ratings, and things of that sort. And here's what that looks like when you do it correctly. You've probably already seen it. You get, instead of 4 lines in a search engine result page, 5 lines. And you get stars, which could be misconstrued as Google's way to endorse your business, which is even better. Because really what those stars represent is the ratings people have left on your product. And you can see whether or not it's in stock, whether or not the price is within your range and stuff like that, how many reviews have been posted. Really, really great. You can also use the same technique to designate breadcrumbs and stuff like that. And you can test your work as you go through it and as you implement it. There's the structured data testing tool. You give it the URLs you want to test. It'll show you what the semantic parse data might look like at that point in time. Thanks, everyone.
All right, so we have some time for questions. Anyone with a question? Yes? No? Oh, back there.
Do you have any suggestions for how Spree should maintain permalinks or slugs in the new version in terms of them changing and keeping the SEO juice still to your page?
I'm not sure if Spree 2.1 or 2.2 is trying to change the way the permalinks are being displayed by default. We still use the convention that's been going since 0.0.11, which is /products/ whatever the actual permalink of the product is. And that is good. So in our case, many products, this is actually a very good question, very relevant to what we're doing. One product may fit up to, I've seen a product that fits 10,000 vehicles, mostly because it's a windshield wiper and cars reuse the same ones over and over again. The link to that product appears on thousands and thousands of product browsing pages based on what make, model, year, engine, submodel you select. So the problem of canonicalization and permalinks is very important there. I would recommend for cases like ours to link to the very flat URL structure, /products/ whatever the permalink is. That will keep all of the SEO juice from all of those browsing pages flowing through the one exact product detail page instead of trying to nest that permalink in every category that it appears in. And if you are going to do that, then definitely make use of the canonicalization slug and tell it some sort of a single location that it can link users to if they're not actually browsing your site and if they're landing on it using a search result page.
What about changes to a Spree product permalink? Because right now the consequences aren't that obvious in the admin tool that if I change something from like /product/BMW muffler to BMW whatever, that all of that goes away. You start serving up 404s to Google.
Totally. This is probably something you can solve on your own end with some sort of a data store, which might slow you down a little bit, or it might not. For things that are really worth a lot of money, what we do is we actually manually have gem, or you can even do it in your Nginx, basically a list of manual redirects for things that really carry enough value to the business that you just go in and deploy that. What we do is we have an initializer file with a hash map of previous URL to a new URL that we can deploy in a matter of minutes. And we do it not on a global basis of URLs. We actually do it on how some people might misspell makes, what the possible model misspellings are. Maybe somebody abstracts VW instead of Volkswagen typing that out. And we actually do those redirects on model basis, not on URL basis. So that's probably the way I'd recommend you tackle it too.
You mentioned as part of the canonicalization, keeping the URL structure flat. Related to that, have you seen any SEO benefit to, instead of, for example, doing products / Acme windshield wipers, making that products a category specific one? So windshield wipers / Acme windshield, keeping that as the one canonical, but just tweaking that first folder name.
That could work very well. Basically, the things you have to worry about when you nest URLs is you want to make them trimmable, which is what our entire URL scheme is. And that would be obviously a benefit because now the keywords appear in the URL, and Google likes that kind of stuff. As long as that does not incur extra performance cost. In the case of an Ember app, you would actually go to that category first, do whatever database calls it needs to, and then do the successive interaction database calls to represent that state. Which wouldn't be ideal unless that actually is rendered on the front end, like there's a sidebar with the selected category or whatever, what have you. But that's a perfectly valid approach, and yes, we did used to do some things like that, and I would imagine there's benefit in that, but unfortunately I don't have benchmarks. That is perfectly in line with what Google suggests to do in those kinds of cases. Again, you would find answers to all questions like that if you actually read Webmaster Tools. They tell you everything you need to know. Everything that somebody's trying to sell to you as an SEO firm that's not mentioned in Webmaster Tools, it's either not worth it, complete speculation. The only way it could ever be valid is if they actually have set up tests with honeypots online that have been deployed for a long amount of time, 3 months or longer, that they can show you data on. That's the only way it takes recommendations in that form.
Any other questions? Nope. All right, Dennis. Thanks very much.
Thank you.